Welcome, ladies and gentlemen, to this video lecture. So in our previous video we wrote out a proof outline of how to prove the sum law for limits. Let's fill out the details in our proof outline. So we assumed here that this limit holds and this limit holds. And I've written out here in purple exactly the meaning of the statements that we are assuming. And we have also spoken about the shop metaphor. So these shops, if we pay with epsilons, these shops will build us deltas which work with these epsilons. And I've labeled these shops shop A and shop B. And we have to show that the limit of the sums is equal to the sum of the limits. And that means something very specific. It means we need to show for any epsilon, we need to be able to find or construct a delta so that if this holds, then we can say something about f of x plus g of x minus L plus M. Okay. So let us start here. Let's start with this thing. This thing, keep in mind, this thing we want to have less than this epsilon that we started out with over there. And we know this L is connected to this G, to this F, and this M is connected to G. So let's rearrange this as follows. This is equal to f of x minus L plus g of x minus M. And let's put some brackets around here. And why don't we apply the triangle inequality here? F of x minus L plus g of x, g of x minus M. And now we see here, this is something that we have control over. How can we control this thing? How can we force this thing to be small or to be something to do with epsilon? We can control this thing if we go and we buy an appropriate delta from shop A. And similarly, this term we can also control. We have control over this term. How can we control this term? We can control this term because we can go buy something to do with that term in shop B. You see here, there, and there are terms or expressions that look suspiciously like the ones that we have here and here. Okay. So in the end, what do we want here? We want this thing to be, this entire thing to be less than epsilon, where that epsilon is this one that we have defined up here. So we fix any epsilon greater than 0. Let's split up this epsilon into two parts. So let epsilon 1 be epsilon over 2 and epsilon 2 be epsilon over 2. And now, well, of course, this is positive, that is positive, because epsilon itself we chose to be positive. Now, why don't we go buy a delta 1 from shop A to work with epsilon 1, and why don't we go buy a delta 2 from shop B that works with epsilon 2 and see what happens. Let's do that. So I'm going to write it like so. From A, we know that there exists a delta 1 greater than 0 How do we know that it exists? Because the little artisan who lives or who works in this shop will build us one if we give him this epsilon 1. There exists a delta so that if 0 less than x minus a less than delta 1, then f of x minus L is less than epsilon 1. And notice here this delta 1 that the artisan built, or that we bought from the shop here, he works with epsilon 1, with the epsilon that we paid with. And now we do the same thing with epsilon 2, but we go to the other shop. From B, there exists a delta 2 greater than 0, so that if 0 is less than x minus a is less than delta 2, then g of x minus m is less than epsilon 2. And maybe for good measure, let's write out how epsilon 1 and epsilon 2 are defined. They are defined as epsilon over 2. Each one of them, epsilon over 2. Okay. Now let's think. What are we allowed to use in defining our delta here? We are allowed to use any of our previously defined symbols. We are allowed to use, which symbols did we define previously? Epsilon, epsilon 1, epsilon 2. But now we also have this delta 1 that we bought and this delta 2 that we bought. And we see if, under this condition, this term is less than epsilon over 2. And under this condition, this term is less than epsilon over 2. So if we can get this condition to always hold, we see that this term we can get epsilon less than epsilon over 2, and this term to be less than epsilon over 2. And if we add epsilon over 2 to epsilon over 2, we get epsilon, which is exactly what we want. Okay, so now we want to force this condition to hold. So by assuming this, we want this to hold and we want that to hold. And now what we do is we take delta to be the minimum, the smallest one of delta 1 and of delta 2. Then, maybe let's move this down a little bit. Then delta is less than or equal to delta 1, and delta is less than or equal to delta 2, because delta is defined to be the smallest one of the two. So he is smaller than or equal to both of them. And now, if we assume that this holds, then automatically we get x minus a is less than delta, which is less than or equal to delta 1, and 0 is less than or equal to x minus a, which is less than delta, which is less than or equal to delta 2. So in making this assumption with our delta that we defined over here, we get that this condition holds and that this condition holds. But how was this delta 1 constructed and how was this delta 2 constructed? They were constructed so that if this holds, then that holds. So let's call this star, and let's put it like so, and let's call this triangle. So here this is less than epsilon 1 plus epsilon 2, and let's put here where does this come from? This comes from star and from triangle. Well, let's write it this way. Star and triangle. By star and triangle. But by definition, these guys are epsilon over 2, which is equal to epsilon. Okay. And there we have proven the sum law for limits. So let's go through here, and this is now our proof for realsies. What do we have to prove? So let's go through everything again. We prove if this limit is L and if this limit is M, then the limit of the sums of f and g is equal to the sum of the limits. How does the proof work? We want to prove this implication, so we assume the hypothesis, we assume these two statements, and here I've written down what these two statements mean. Think of these statements as shops. We fix any epsilon greater than 0. We split this epsilon up into two, epsilon 1 and epsilon 2, just by dividing epsilon by 2. We take our epsilon 1, we go buy a delta 1 at shop A. And you take your epsilon 2, you go to shop B, and you buy a delta 2, which works with epsilon 2 and G and M. So now we've got this delta 1 and delta 2 to work with. We define our delta to be the minimum of the two, because then delta will be smaller than delta 1 and delta will be smaller than delta 2, so that if we make this assumption, assume that x minus a in absolute value is less than delta, then we automatically get that this condition over here is automatically satisfied, and this condition over here is also automatically satisfied. And then we put everything together. We are interested in this expression, which is equal to this, just by rearranging, apply the triangle inequality, and now we just interpret what we have. This thing is less than epsilon 1 under what condition? Under the condition that this x minus a is less than delta 1, but we have that. And this expression is less than epsilon 2. Under what condition? Under this condition, that x minus a is less than delta 2, but we have that from how we constructed our delta. So this guy is less than epsilon 1, this guy is less than epsilon 2, but how did we define them? We define them as each one of them as epsilon over 2, which sum up to epsilon. Okay, and that is the proof of the sum law for limits. And we shall do another one of this ilk, because even though it is rather straightforward, let me say that I don't think that this is easy. There are lots of little things that add up together to get you to this proof. Okay. I will see you in the next one.